Good day, Dr. Ron McFarland here with an introduction to computer science. Our topic today is a distinction between procedural and object-oriented languages. We'll talk about procedural-oriented languages and object-oriented languages and the design thinking behind the two general concepts. First, procedural-oriented programming, or POP. Here's the general topics. Procedural-oriented programming, top-down thinking. Concepts about POP. I have an example of POP in the C programming language. And POP's focus, the positives, and drawbacks. Now on the screen, I have a picture of the backside of a cake mix, a vanilla cake mix, and that kind of represents a very linear process that we might do perhaps in the kitchen, something in real life that we would do, but we could actually use this as an example of how POP programming can work. Again, it's top to bottom. When you're doing a cake mix, you do step 1, step 2, step 3, and I would imagine step 4, which isn't on the cake mix box, would be consuming the cake. So anyway, let's kind of use this as an analogy. Again, up on the upper right hand side, I put a note, top-down thinking. Essentially, it's what we need to do first, and then what's next, and then what's next, and then what's next, until we're done with the entire process, if you will. So that's top-down thinking. Over on the right-hand side, we have inputs defined, and in this example, we have eggs, water, and oil. Certainly in a C program, we would have our input defined, perhaps up on top. Next, we'd have the step-by-step process. I also indicated on the right-hand side functions. Well, functions could be groups of processes that we would perhaps repeat over and over. Rather than writing the code over and over again, the same code over and over, we can bundle a small group of code into what's called a function and just keep calling that function over and over again in the program as we need. For example, I noted preheat, grease, and flour could individually be functions, and those individual functions could be stored off in the library. And if I was writing another program instead of vanilla cake, for chocolate cake, I would use the same 3 preheat, grease, and flour functions without having to recode those items. Again, on the left-hand side, the key items with procedural programming languages would be a step-by-step design approach. Everything's done in a sequence. Again, it's linear from top to bottom, and I know there's exceptions regarding program flow control with if statements and while statements and do while statements that could vary the execution of a given program, but the essential notion is from top to bottom or top-down thinking. Here's an example of top-down design. This is a flow chart and up on the top you'll see the start box. Way down on the bottom you'll see the end box. And this design type is to represent how you might think about a top-down design program. Let's say if this was a C program that you're writing, or it could be done in Fortran or COBOL or many of the other languages that are more prone to procedure-oriented programming. So up on the top we have start. We have the read input. That's where you would define your variables. It does some initialization up on top. And then it start right in the middle. It's either a do or do while loop, and it checks for true or false, and it's accumulating numbers in a variable or a bucket, if you will. And at one point in time, it looks like it's putting out a result, and then the program ends. But the whole notion of this design is from top to bottom. Some of the concepts about POP, procedure-oriented programming. C programming language is an example, as we've noted. Fortran, PL1, COBOL, and in fact you can take C++ and make that operate very much like a procedural-oriented language, if you will. Procedure-oriented languages are action-oriented. Their main question is what needs to be done next, and then what needs to be done next after that. Top-down execution, I've noted that a couple of times. And code can be placed in functions. Again, function is a group of code that could potentially be reused over and over again, or either in that program or perhaps stored in a library and copied into another program for use there. Now, data is mixed with the processing. What that means is your variables are mixed in with the code. And we'll see in contrast with object-oriented programming, there's a separation there. So variables are mixed in with the code in procedure-oriented languages. Here's an example in C of a procedure-oriented program. Again, there's two functions here, and the process is very linear. There's two functions. One is called the fun function, and down below is a function called main. The execution happens to be in C starting with the main function, and there's a linear step through, if you will, of gathering the clock information, and then it executes the fun function, so it bounces up to the top and linear executes that fun function, and then returns back and sequentially goes down through the code. So it's a very linear top-down process. Again, functions are groupings of code that are placed in a function. Input, define what you need before a process is the typical way of handling procedure-oriented programming, and it's a step-by-step execution. For POP, here's the focus, positives, and drawbacks. The focus, again, is top-down and sequentially processed. Now, you can create functions that are pieces of code that can be reused. Again, a language like C requires one function, the main function, and all the others are optional that the programmer can decide to bundle up, if you will. Some of the positives, I say positives multiple because C or some other procedural languages can be more terse, more concise, and can be potentially more efficient, and that comes into play with certain environments like Internet of Things, smaller devices, perhaps more unique devices that may not have as much RAM or storage space, if you will. The drawbacks, data moves more freely in the program construct, and that has an impact on data security. That's a big red flag. In my security courses, we go in depth on the impact of procedure-oriented programming on security and all the risk factors. Code reusability is difficult to non-existent. Now, I keep mentioning here, I've already mentioned it several times, that you can build functions in a language like C and store those functions off in a library that you can use in other programming, and that would be one way to write once and use many. But you still, even if you're calling a function in from a library, you still need to test it out thoroughly, and the demands on testing might not be as rigorous to some regard in OOP with some of the external objects. Now, code can be a lot more complex in a procedural-oriented language in contrast to object-oriented. One thing is there's also an increased cost over time with POP due to program maintenance and change requirements. If you're building a large program in C, for example, for an organization, over time they'll have change requirements that come into play, and those can get pretty sticky and require additional code to be inserted in different places in the code stream, which could result in what some folks will affectionately call spaghetti code. So then the code becomes a little bit more unwieldy. The maintenance and expense to maintain that code begins increasing quite a bit over time. Let's talk about object-oriented programming. Object-oriented is bottom-up. I like using an example from the real world. Here I have a couple of Legos just scattered on the table. They're all the same size, just different colors. A Lego object, we can call it an object class. A Lego object has a size. These are all the same size. An object also has a color. There are different colors in this instance. An object has a number of connectors on the top and the bottom, and they are all the same type of connectors on these objects. So we're defining an object class here with this example Lego. It's bottom-up thinking. How many Legos do we need of different sizes and configurations to make a small building? Then, how do we connect each of these different Lego types to form the building? The concept with object-oriented programming is to define all the objects that you need and object instances. I'll talk about that difference in just a second. And then how do we put these objects or pieces together? Here's an example from the real world. Bottom-up thinking. What do we do for a driverless car system? Now maybe that's the definition of an entire system. We want to start looking at the particular objects that are in a driverless car system. First thing you think of is a car. Now, down below I have two pictures of not driverless cars, but let's just say cars in general, whether they're driverless or not driverless. Now, that car in general is considered a class. A class is generalizable template for an object type. Now, for any car, you have attributes. You'll have perhaps fuel type, the maximum speed. You'd have perhaps entertainment center. You'll have all these different attributes, all these different features that you can have. So that attribute list can be quite extensive for a car. Now the methods are the executable items that can happen against the fuel or against the max speed or against the attributes. For example, we have a method of refuel. We know that refuel can only perhaps fuel up to the maximum that that car can hold. For example, if the attribute of the Toyota car on the right-hand side, maybe the fuel type is gas and the maximum fuel as another attribute is about 10 gallons. We know that refuel can only fuel up to a maximum of 10 gallons. Whereas I suspect the BMW has a larger fuel capacity, so the attributes or the data related to that BMW, the fuel capacity would be perhaps 14 or 15 gallons. So here we have in the car class, we have the methods, which are the programming, and the attributes, which is the data, and there's isolated within the class. The methods perform an action against the attributes. Over on the right hand side, just some of the definition. A class is a generalizable template. The class instance or an object, and I put class instance or an object, it depends on the language that you're using, but the object instance is a specific implementation of a class. Let me say that again. An object instance is a specific implementation of a class. For example, the BMW is a specific implementation of the class called car. And Toyota Yaris is a specific implementation of a class called car. So we have two instances, if you will, of down below. One is a BMW, and the second one is a Toyota Yaris, but they're both instances of the class called car. Let that sink in a little bit. That's kind of the essence, if you will, of object-oriented programming. Again, just kind of a recap, attributes are descriptors of what the object or thing is. Descriptors include fields, could in files, data types, all the data. And you can see over in the green box, the attributes are isolated from the methods. The methods are code that modifies the data. Now, if you're thinking in terms of procedural code, maybe if you know C programming, a lot of times those methods look very much like a chunk of a C code, if you will, if you're using a similar language. So it's just code that acts on the associated attributes. So again, we have class. Class is generalizable, and we have a class instance, which is a particular implementation of the class, and the methods and attributes that go along with that particular instance. Here's a design example of a button. Now this button could be part and parcel of an entire information system. Imagine an information system that has, 40 or 50 different screens. I've seen large information systems like that. Well, you could have buttons of various sizes on different screens depending on what the function does. Well, this button class, if you will, may have attributes like X size, Y size that define the size of the button, a label, the interested listeners, which screens perhaps are using the button, and the X position, Y position on the screen that button lives, if you will. So you'd have a button class and then multiple button instances with the X, Y sizes populated, if you will. Down below you've got the methods for each instance. The draw method, a press method, callback and on register callback method. Perhaps those things do things whenever a user interacts with a particular screen. So that would be an example of some design thinking regarding a button class. Now Java is an example of an object-oriented language. We also have C#, C++, Python, and Ruby. OO programming encapsulates data, which is attributes, and behavior, which is methods, together. An OO language is object-oriented, and the main question is, first, what classes are needed for the program, including methods and attributes? And second, what object instances are needed to accomplish the task? Here's a Java program that displays the current date and time on the right hand side in the result panel, and the left hand side is the actual code, and it calls in an object date as an object class and creates an instance of it called date and prints the current date off of that instance. So this would be similar to calling in the car class and creating an object instance called car. We could probably call it Toyota Yaris car as an instance, and then displaying out, if you will, some of the attributes. And by the way, this was compiled using Coding Ground, which is another IDE online compiler that you can use. Let's talk about the focus, positives, and drawbacks of OOP. First off, the focus. The main unit of OOP is the object classes. And within those classes, think of all the attributes that define the data and the methods that act on the attributes. And within each class, you have class instances or object instances, again, I use those almost interchangeably, and that is dependent on the language. Some of the benefits in increased data security because OOP binds the data closely to the function. Reusability is enhanced with objects because those objects are individually tested and then perhaps stored in an object library to be used later. Some of the drawbacks, it's a lot more time consuming to design classes and methods in an OOP environment, but the benefits, in my opinion, outweigh the drawback of extra design. Let's go for a quick summary and recap between POP and OOP. Procedural programming, variables are identified. Instructions are written to use variables in correct sequence to obtain desired results. Instructions can be placed in the blocks of related code or functions. Common uses for procedural programming is scientific and engineering problems in general. Now, object-oriented programming, objects are defined. People, places, things, anything you can assign a noun to, that would be an object. And every time you think of objects, an object always has some sort of attributes. A person is an object. Okay, I might get some feedback on that. But a person is an object, has or hasn't hair, typically arms and legs, color of eyes, and that sort of thing. So a person is an object with attributes, and the related data is attributes that will use methods to act upon those attributes. Methods are essentially little snippets of code. Because of the design of OOP is on the behavior of object, there is greater flexibility in how objects can be used and implemented. Now, that particular item has an impact on the cost of an information system over time, which is a positive impact, whereas it's a negative impact on procedural programming, because as procedural programs age and more requirements are thrown at them, the complexity increases in procedural program, so does the cost. It's inverse in object-oriented programming in general. The common uses for object-oriented programming is software packages. Now, we went over a couple examples that were sort of related to software packages, if you will, and OOP has a broad market reach. Well, thank you so much. For any questions, if you're in the course, post them in the discussion thread. Or if you're just watching this on YouTube, great. Just reply in the YouTube window or send me an email. I'll post the video link for the course in YouTube once I compile and upload it. Thank you so much again. Bye.